Let's continue the previous video. So that's why, right, actually we finish here if you have compared EAX. If EAX greater than 1, actually we need to continue to the recursive code. But this recursive code, what we finish here, they only call the n-1 recursive code. But remember, our recursion function, what we want is not only you need to go the recursive code, it's your result actually multiplied by n. So that's why here, right, we finish the recursive code for n-1. But what we need is this one for the final answer. So that's why after you call the factorial function with n-1, so then after they can come back, remember here, you call this factorial is for n-1. So that's why after they return back, right, they will continue with the line 81. So after you come back line 81, you will get what? You will get EAX is n-1 factorial. So now we need to use this one to multiply by n. So in here, which one is n? Right, n is here, right? N being pushed before. Just before we're using the EAX to save the n. But now I need to retrieve that again. And also since I need to use the multiplication. So when we do the mode, remember our mode we're using the EAX to multiply another number, right? So that's why here I need to get n again from my stack. So after I get that, I move to EBX. So this one you can use in other any 4-byte register, but not EAX. Because the EAX we need to use from here. After you get the n from the stack, so now after you return from this n-1 factorial code, so then they will call, because after you call this one, they will update. Remember, we update EAX value is the return value. So that's why they multiply by EBX. So then, yeah, we finish the recursive code. So again, after we finish recursive code, right? So then you will see the next line is what? Right, the next line is wrap up for the return from the procedure. So that's why we have the EAX is the result. So we pop EBX to recover from our procedure. So then we return 4 because we have the stack memory we need to clean up. So this one is your recursive factorial function. Okay, so you can compare to the handout later we show you. So hopefully this one will help you to understand why this factorial function will be called like that. So when you download, I give you the example, right? So your ASM factorial.asm file for this one, okay? So this one actually including both your to call a loop or the output for the recursive code. So that's why here in the main function, the first one we will call the factorial. So you will see both for 5 factorial using the recursion code or 5 factorial to using the loop. They should be the same. So please make sure you download this file and run from your Visual Studio. So after you understand how you implement your factorial recursion function, we just quickly using one example. We just use the 3 is enough because we have so many recursion code. I want to show you how the memory stack will happen. So we will see here, we just push 3. So that's why you see n equal to 3, you push. So you call factorial. Whenever we call factorial, remember you have return address. So then procedure start, you have the EBP. So you push the EBP. Okay. So remember, besides that, we don't have anything anymore. But one thing is, in your factorial function, remember, you also call n-1 factorial again. So that's why inside your factorial, you have n equal to 2 again. You call that function. So then they have the return address. Then they have their own EBP. So again, because n equal to 2, I need to continue to do n equal to 1. So n equal to 1, I call recursion function again. So then I have my return address. Then I have my EBP. Okay. For the example I show you, you can either do compare EAX equal to 0 or 1. Actually, for my example, I do 1 only. So that's why after you're done here, they finish. Because after n equal to 1, so finally they will return. So that's why you will see here, when you have your recursion code, if you have more parameter list need to return. So that you see you occupy 4 bytes. So then you have return address. Then you have your EBP. So that's mean every one procedure code, you have 1, 2, 3, 12 bytes. So even you only do the 3 factorial, you will call the function 3 or 4 times. So that's why your memory will use that much. So even cannot think about how about you want to do 12 factorial, or actually earlier I want you to run 40 factorial. You will see what happened and what is the value. So for the factorial example, they have 2 situations the output won't be correct. The first one, sometimes your factorial is big enough, your ENX already cannot hold that big value, so then they already overflow. Or even you can calculate that. So but when you have more factorial number you want to do, your memory stack will overflow. Okay. So I hope after we access those memory process in the stack memory can help you to understand from the other classes when we talk about recursion function. Sometimes recursion function is easier for us to implement, but the drawback is really you will see the memory stack. They're using a lot of memory, but before you cannot really imagine what kind of memory they use. But that's all the memory stack. You will see how they will access one by one.